So hi guys, good morning all of you. Guys, I'm audible. Okay, right guys, and now we can see. So yesterday, up to bitmap index we discussed here. Okay. And now we will see the bitmap index internally, how it was working. Okay. So now you can see. So when we created what we said in the last class here, so whenever we created bitmap index on low cardinality of column, internally system is preparing a bitmap index table. Okay. And with bit numbers are 1, 0. Here, bit number 1 is represent condition is true and 0 is represent condition is false. Okay, here every 1 is nothing but what we said here. It's a row ID indicator. So in your table, whatever and how many rows are there. So in that rows, each and every row is having row ID, and already we knows that. So every row ID indicating what now? 1. Okay, na? So that is what it was happening. And now we can see, now we will go for, okay, how this internally work. Okay, and now we can see, guys. So this is your table. The table information, I just go to call now. Okay, right. And now I'm going to create my bitmap index. But how the bitmap index will be created? Okay, go and check it out. What is the syntax for creating bitmap index? Create bitmap index name. Okay, bitmap index name on table name of. So now your required column name should be give it now. Okay, now right. So now here, okay. So what we want to do, guys, here. Okay, based on the syntax, now I'm going to create a bitmap index. Okay, let me see how I'm creating. So now I'm going to create a bitmap index, and index name is bit. Okay, bit 1. So on my EMP offer, suppose, let me see, guys. Now I'm creating my bitmap index on one of my job column, for example. Okay, now, because why I'm choosing job column means yesterday we calculated, so cardinality of your job, how much here, which was 0.35. So which column cardinality is less than, okay, 1, we said bitmap should be preferable here. The performance wise, it will be good for us. So now here, so job column yesterday, EMP number, name, these cardinalities are 1. Okay. But when we go for cardinality of job, it was 0.35. So that's why I'm going to prefer to create my bitmap index on my job column. Okay, now on my job column, I'm going to preparing here. Okay, let me see. The bitmap index is created here. Carefully observe, it was created. After created, later what it was happened, suppose user has to send this request, okay, to retrieving some data based on job column. For example, if I want to say, so whose job is equals to clerk. So who are working in the clerk departments and who are working as the clerks. So those people, okay, information, I was given job is equals to clerk. So based on this request, what the system will do, okay, it will be preparing what now bitmap index table is prepared. How the bitmap index table is preparing here, let me come out and see. So the internally what it was happening here, come out and see this. Okay, na? Right. So here, how the bitmap index is created. So now I'm taking your bitmap indexed table. Okay, na? Now we can go for to here, which column wise we design your bitmap index here, job column wise we designed. So the job column wise we designed. So job is a column. Okay, na? Right. So now here observe. Here observe. Okay. So now the index table will be preparing based on job column. So it was preparing like this. Okay. And now, so job is my column. Okay. And now see here in my table, carefully observe. In my table, how many rows we have, guys? 14 rows are there. Okay. That 14 rows I will take now. Okay. So first row, second row, third row, fourth row, fifth row, sixth row, seventh row, eighth row, ninth row, 10th row, 11th row, 12th row, 13th row, 14th row. So these are the 14 rows. Clear now? Now, so what is my condition here? Job is equals to clerk here. So here it will be taking, the table will be forming like this, clerk. Okay. Now, so after that, let me see how the system is arranging your bitmap index table means. So first it was checking job is equals to clerk. So first one is clerk. Clerk is equals to clerk. Condition true or false? Come on, guys. Clerk is equals to clerk. Condition true or false? Yes. So condition true. Condition true means what is the bit number here? Bit number is 1. Okay, na? So my first row, it was a true. Okay, na? My first row, it was a true. So 1 it will be taking us 1. Okay, fine. Then come to second row also verified here. Your system is going to be verified. Second row, what is the job here? Salesmans are there. So salesman is equals to clerk. Condition true or false? Yes, condition will be false. So false means here 0. False means here 0. Okay. Next one is what now? Third row I have to check. Third row, check it out here. Again, salesman is there. Again, salesman means condition false. As per this condition, it's a false. If it is a false, and now it was taking again 0. And the same to same, now I'm going to taking here fourth row. Then fourth row, you can see it was their manager. So manager is equals to clerk. Okay, manager is equals to clerk. So that means here also condition false. Then it will be taking 0. Again, it will be taking 0. Next, fifth row. So like you're understanding now what the system will do, each and every value will be arranged here. So salesman, again false, manager false, analyst false, president false, salesman false, clerk is true. That means it is a 9th row, 10th row, 11th row is true, 12th row is true. Next 13 false, 14 true. So 11, 12, 14. Remaining all are zeros. So 0, 0, 0. So all are zeros. 0, 0, 0. Okay, now. And the next one is called as 11th row true na? Yes, 1. And 12th row true na? Yes, 1. Next 13th row false. Yes or no? 13th row false. 14th row true 1. Okay na? Right. So now here what it was happen. This is the way the bitmap index table will be arranging as per the given condition. It was arranging like this. And what we said here, 1 is representing row ID. So as now what happened, as per this request, now Oracle server will come to this bitmap index table. Come to bitmap index table and searching now. So now searching. So first here 1 is there. So 1 means row ID. So suppose this row ID is nothing but, okay, you have A. My row ID is A, suppose. So what it will do as per this row ID, directly will go to your table and this row will be picked because this row ID is also A. So A where it is, A means row ID means what I said, it's a page number. It's like a page number. So A here there. So A immediately, okay, finding and picking that. Directly go to A and pick this. Next, so what it was happened, these are the zeros are there. Zeros will never touch. Zeros are never check. And directly what it was going to be happen, as per this A, okay, and directly it will be jump to 11th row now. So 11th row, for example, N, MN, okay. So previous something, some yes or something will be take here. So based on this row ID, directly what it will go here? So directly 11. That means first row, it will be pick from this table. Okay, now. Then after, it was directly jump to 11th row, it will be jump now. So here, this row will be picking. After 12th row condition also true. So this row also picking. Then after directly go to Miller. This row, sorry, Miller. Miller is also picking. Understand my point now? So that means what happened here? The wherever zeros are there as per the given bitmap index table information, wherever zeros are there, these are all our zeros now. So this is 0, 0. These are all our zeros. So these zeros are or 0 rows are your server will not searching. My point is got it or not? Server will not searching. So directly going to first row, directly going to 11th row, directly going to 12th row, and directly going to 14th row. Got it my point now? So like that means total number of rows in my table 14. Out of 14, how many rows are not searching? 10 rows are not searching. Is it correct or not? 10 rows means each row will take a 1 second of time. Then how much time saving? Come on, you are saving time how much here? What is your saving time? 10 seconds of time saved. Okay. So 10 seconds of time saved. This is bitmap index table advantage. Got it my point now? So wherever zeros are there, these 0 rows are your Oracle server will not search. Wherever 1 is there, directly based on that 1 is nothing but row ID. Based on that row ID, direct will jump to that row ID and row will be pick. Got it my point now? So remaining rows are not searching. So that means here searching time will be reduces. The searching time will be reduces. If you go to table scan, how many seconds? 14 seconds. Because each and every row will check 14 seconds time taken. And now we are going to save how much? 10 seconds we save. That means our data was get it within 4 seconds. Got it my point now? Table scan, our data getting purpose 14 seconds. But now I was get it my data, same data, with 4 seconds I get it. That means 10 seconds of time is saved. Got it my point? That means 10 seconds of time is saved. This is what advantage of a bitmap index table. Got it? So these are what we called as guys here, B-tree and bitmap indexes are how it was internally working and how the searching time will be reduces. How the searching time will be reduces. Okay, now how the searching time will be reduces. Got it my point here? So this is okay, the B-tree and bitmap indexes. Now we will see, suppose these indexes, do you want to view in your table, okay, in your database, you want to view then there is a one data dictionary is there, user underscore indexes. Let me go. And yeah, so many are there here. In this one of my column, index name and index type. These are the 2 columns are there in the data dictionary. Do you want to see that? Which indexes we prefer and created? Select index underscore name, index underscore type from the data dictionary user underscore indexes. Okay. So where table underscore name is equals to what is my table name here? EMP. Okay, now carefully observe. I1 is showing as index type here. This is index name. So on my EMP table, total 4 indexes we created. One is I1. I1 is showing index type is normal. I2 normal. FI, that's called a functional index here. There's a functional based index, this is, and it is also showing normal. And bit 1, it's showing a bitmap. Okay. So what is the mean by normal, sir? Means that normal is nothing but a B-tree indexes. The wherever normal is showing that, the normal is called as a B-tree indexes. Okay, na? So normal is nothing but B-tree indexes. So this is also B-tree index. And this is what bitmap index. Okay, now. So why, sir, normal will consider the people as a B-tree index? Somebody's have a doubt. Okay, because of reason, what is the default index of database means the default index of database is called as a B-tree indexes are default indexes. Okay, now if anybody asks you what is the default index means, B-tree indexes. Okay, now B-tree indexes are default indexes we called. That's why every normal, whatever it was showing here, every normal type is representing B-tree index. General indexes, normal indexes. And if bitmap index is clearly showing bitmap indexes. Okay, right. And these indexes, when you want to drop, then we have a syntax drops, okay, index I1. So it will be dropping. Same as if I want to drop functional index fi is also drop. Same thing if you want to drop bitmap index 1, it is also drop. Got it? So all indexes are successfully dropped. If you want to see your, okay, so only index number 2 only there. Okay, so this is what is the advantage and the purpose of your B-tree index. Okay, here last finally. Okay, in the main material, you have a clear notes. There is nothing problem. How to drop index. Okay, what is my syntax for this? So drop index and we'll go for index name. Okay, and now the example. Okay, I'm going to give drop index and index. Okay, I1, whatever you want to take it here, which index you want to drop, you can drop it. Okay, and the same thing previously, can you see we are creating indexes on a DEPT table also we designed. Can you remember? Yes, DEPT table we created, unique index we created, but unique index is also showing as what now? Normal index it was showing. So that means it is also one of the type of B tree. And this index also, if you want to drop here, so you can drop like a UI and it will be successfully dropped. Okay, no? So these are the indexes mechanisms, and generally these indexes in real time. So Java people don't they don't want it. Java, .NET, Python people, they don't want it. This is mostly the people database developing side who are working. Okay, who are working as a database developer. So those people are going to be using these indexes. But if you are a Java student, you don't have interaction with this. Okay, so Java, .NET, Python, these people is not going to be using these indexes because they don't have that kind of operations to work here. Okay, these are prepared by database programmers. Database programmers will apply, or database developers are apply. Okay, now, so this concept I'm telling. Okay, so these are what we called as guys here indexes. Okay, then I will go to upload these notes. Okay. So finally, okay, after SQL is completed, now SQL part is over, I will give some important topics for Java students. So Java, .NET, Python, AWS, DevOps, data science, so MSBI, Power BI, these people, which concepts are mostly focused on it. While you're going to any Java interview, Java person, that means if you're going to Java interview, but they're asking some database questions. Okay, then which areas they will mostly focus on, okay, in Java interviews, .NET interviews, Python interviews. Okay, so after SQL topics are completed, finally I will give some important topics for you. Okay, na? And who are Java, .NET, whatever I said, Python, AWS, Selenium, DevOps, MSBI, Power BI, data science, these people, only those concepts we have to focus it. Okay, na? And because in this course, I said this is a database developing course. That means if you are in, if anybody is there, he was trying to database a developing position. Okay, na? Suppose, sir, I'm not a Java student, I'm a database programmer. I want to try my jobs on database side, sir. If anybody is there like that, they wanted this entire concepts, whatever we are learning. Okay, but who are going to front-end related things, okay, some special tools, so they need a few topics in this. Those few topics, what it is, after finishing SQL part, then I will give to you. Next term, PLSQL we started. In PLSQL also, these guys are not required all the concepts. So one Java student, which concepts they are using in their Java projects from PLSQL. So those are also I will give to you. Okay, so from SQL, some topics, PLSQL, some topics. On these topics, you have to focus it. Especially these people I'm telling. Okay, but you are a database programmer. Sir, I'm a database programmer, sir. I'm trying database side job. Okay, so those people, the concepts will be know it because they're purely working on database side. Okay, now that's why those people need a complete syllabus. Okay, so that's why here we are teaching complete syllabus for based on database developing position basis we are teaching to you. Okay, now, but in this few concepts, Java people can take, Python people can take. Okay, now that what it is, finally, I will give it. After SQL, some topics I'm giving to you. After PLSQL, some topics which is important for you. Okay, on this, you have to focus who are going to Java side, .NET side, Python side. Okay, now Selenium side, like this. Okay, right. So now this is, I will be uploading here. Okay, right. The complete running notes I uploaded. Next, and come to the next part here. Okay, the next another topic in SQL part. So that was called as here cluster. Okay, cluster. So what is clusters? And these clusters, again, database programmers. So where he was applied these clusters and why they applied the clusters. What is the advantage of clusters here? Okay, now, yeah, careful observe. First, I will give some explanation. Okay, why we required clusters. Okay, na? And after that, I will show you practical how to do. Okay, right. So basically, cluster concept and general meaning. I'm asking to you guys. Tell me what is the mean by general meaning of cluster in English word? Cluster means what now? Anybody have idea? What is the mean by cluster? Come on. Yes. Somebody sending clustered group of people, groups, collection. Okay. Yeah, very good. Yes, correct. So cluster means what now here? Group of objects. Okay, collection of objects or collection of items, group of items also we can call. Okay, so here also these clusters, that means why should I want to keep a group of tables, okay, in one single memory location? What is the use of, sir? Why we want to keep like this my tables? Okay, now the scenario carefully I identify here. I will explain. Generally, what it was happened, generally, I'm telling first of all, okay, this is your Oracle server. Just assume. Oh, yes. In this Oracle, we are creating one of a database. Okay, suppose my database is called as a, so my DB, otherwise better to this side I will take. Okay. Oh, yes. Okay. My database name is MyDB. Okay, 11 a.m. Okay, na? Right. Keep it this. So I was created MyDB 11 a.m. on database I'm creating in my Oracle server location. Now what it was happen? Suppose users are there. Suppose user is there. Suppose. So this user, whatever the table is created. So some new tables are created, for example. So user is created some new tables. How the new table will save under database memory? How it will be saved under database memory? Okay, na? How it will be saved here? So here, each and every new table, see my points very carefully listen, guys. Later I didn't respond. Okay, na? Careful observe. Okay, na? So each and every table, whatever user is created, every table will be storing under a separate data blocks. That means your database, how your tables can be stored. For example, here T1 table is there. This table will be storing under one data block memory, under database only. Okay, this is data block number 1. Suppose user is created one more new table, and the table name is, for example, T2. So this is also having here one more table. This table purpose also, it was giving some data block locations. Data block number 2. One more table is going to be created. For example, assume, okay, sir, table number 3. Okay, so now one more data block is allocated for this database. So generally what it was happen, guys, here, every table purpose, one separate block is created by Oracle server, and in that blocks your tables are storing. This is the general, that means a natural default. Okay, now okay, fine, sir. But sir, what is the problem when it was storing like this? What is the problem for us? Somebody's have a question. I happily save now, my table data, everything saved now. Then what is the problem for this? Means, yes, the problem when it was occurred. Okay, if you leave like this, nothing problem. And happily you can retrieve data from each and every individual table, nothing problem. But where it was problem here, when you applied joins topic, careful observe my point. So whenever you applied a mechanism is called as a joins mechanism. So when you applied joins mechanism on these tables for retrieving data purpose, their problem is occurred. If you're not applying joins, nothing problem to you. Happily you can go and retrieve data, whatever you wanted, from which table you wanted, you can happily retrieve. But don't use a joins. Without joins, nothing problem. Okay, na? But when you applied joins, there is a problem is occurred. How it is the problem? Let me see. Suppose I'm writing one query. What is my query? Select star from, okay, T1, comma, T2, comma, T3, where T1 dot common column is equals to CC. CC means common column. Okay, na? Already you have a good idea on joins. Again, I don't want to explain. Okay, T2 dot CC and T3 dot, T2 dot CC is equals to common column is equals to T3 dot CC. Yes. This is the one join requirement and one join operation I'm applying on these three tables when I want to need some data from these three tables. And we all of you know, from multiple tables, whenever you want to retrieve some information, definitely we applied what now? Joins. So, okay, na? This is clear up to here. Now, carefully come out. Here, two conditions are there here. Carefully observe. Two conditions are there. This is first condition. This is second condition. Condition number 1, condition number 2. In between, I am applying AND operator. So I think everything you know already. We are explained each and every point in previously. Okay, right. So first condition, we'll check it out. In the first condition, what it will be? T1 dot CC is equals to T2 dot CC. That means T1 table here, T2 table here. First, these two tables comparing as per given condition equal operator. So after comparison, T1, T2, whatever the data will come after comparison, okay, for example, after comparison, some result will come to me. Some result will come to me. Got my point now? Some result will come to me. Again, this result, what database server will do, will save it under another data block, the data block number 4. Okay, so that means first condition, verification is done. Second condition is what now? T2 dot common column is equals to T3 dot common column. So here these two difference again. These two are comparing now. Comparison result will come now. Here also come now some result. Yes, something result is come out here also. Something is come out here. Okay, and this result also, okay, keeping under another data block number 5. Okay, after two conditions verifications are happening, whatever the results was come out from condition number 1 result, condition number 2 results. In these condition results, what I'm using AND operator. I'm using AND operator. Now, in these results, then AND operator will be work. After applying AND operator on these results of condition 1 and condition 2, then it will come to final result. Then it will come to final result. The final result, what it was come as, so the final result will save into another data block number 6. This is called as a final result. And this final result finally sending to whom it was sending? User application, sending to user. So now just imagine internally how much process is going to be happen when you applied joins. Got it? Internally how much, okay, what is the internal procedure when you applied joins? This is what it was happening. And now just imagine this logic I was explained only how many tables, guys, here? 3 tables logic this is. Only 3 table purpose, this much internal process is going to be done by your Oracle server. Then imagine if you want to retrieve data from 25 tables. Because when you're working in real time as a database developer, they're interacting 10, 15, 20, 25 tables are interacting at a time. Yes or no? So now imagine here only 3 tables purpose only, this much scenario is going to be happen for retrieving data purpose. Then imagine there are 25 tables I have, and from there I have to retrieve the data, and those 25 tables are storing like this. Then see how much internal process is going to be happen. Okay, na? Got it? So in this case, what happened? Time consume, performance, especially your join query performance. Your join query performance will be degraded. That means very, very, very low performance will give it us. Okay, my join performance will be low performance. Okay, now this is what it was going to be happen. And this kind of scenario, when your tables are storing like this, na, Individual, na? This is called as a non-clusters we called. This is called as a non-cluster. Non-cluster means not in a group, individual. And what you said, cluster means what you said, group of people. That is called a cluster. But here, group of people are no, individual tables. That's why this is called a non-clustered tables. These tables are not in the cluster. These tables are individually having. So whenever your tables are individually on those individual tables, if I applied joins for retrieving data, then this is the internal execution mechanism. Now tell me, in this case, you have a problems now? Have a problem or not? Yes. So much. Okay. That means first thing is what? Now, join degrading. And it was very time consuming process to doing this all over. So table 1, table 2 first checking and coming some result, keeping into somewhere, again table 2, table 3 checking and coming to some result, keeping somewhere, and later table 1, table 2 result, table 2, table 3 result. Again, these both results are comparing again as per given logic. Then finally it will come. So this is what this much process is going to be happen. Okay, now? So this is generally in any database, how the tables can be stored. How the tables can be stored means all databases are storing your tables in a non-clustered manner. Non-clustered means individually your tables are saved. Individually in each different blocks, it will be saved. So that reason what happened? So calling tables or calling data from tables is highly difficult when I'm using joins. Clear all of you now? Yes. And these problems to improve the performance of joins and save our internal time process, then the people applying what now? Clusters. The people applying what now? Clusters. Got it my point now? Right. But how, sir? How we can overcome with the help of cluster? If I'm creating cluster, how my tables will be saved together in one memory location, and how I can go to apply joins, and then joins performance, how it will be work. Okay, now? So that I will go for to explain tomorrow. Okay, now? So tomorrow explain, and after that, guys, here, 2 more topics are there to finishing your SQL part. One is normalization is there. One is user-defined data types concept is there. So these 2 concepts are there. If it is over in this week, next we enter into PLSQL language. Okay, now? Right, guys. So I stop it here. And once we just practice on indexes and having any doubts are there. So tomorrow I will interact with you for doubt session. Okay, now? So today I have some work. Okay, so that's why I'm taking today I'm not taking any doubt session. Okay, na? So tomorrow I will interact with you. Okay, na? Right, guys. So thank you. Thank you so much.